Hello and welcome to our lesson on solving quadratic equations. This is going to be from section 7.4 in our text. Let's get started. First of all, you need to be able to identify when an equation is quadratic. So every quadratic equation will have an x squared term, and there should be no bigger power. In other words, the degree of your polynomial equation has to be 2 in order to have a quadratic equation. So we're going to look at 3 techniques for solving quadratic equations. We're going to look at factoring, which is usually the fastest technique in order to get to the solutions. However, not every quadratic will factor. So factoring is fast, but it doesn't work every time. We are also going to look at completing the square. That will be a technique that you're required to know. And last but not least, we're going to look at the quadratic formula, which you may or may not have been forced to memorize in high school. So I've got the quadratic formula written here in the red box. We are also going to look at 2 special cases. If you can identify your quadratic as being one of the 2 special cases, there is a fast method to the solutions in those cases. So we're going to go ahead and knock out the special cases first. Here we're going to look at the first special case, which is a quadratic equation where you're missing the bx term. So here we have our ax squared. That is the leading term. The negative 12 is the constant. So here there is a fast way to the solutions if you identify this as case number 1. First, we're going to take the constant to the other side. Moving the 12 over makes it positive, and then we're going to get rid of the lead coefficient, dividing both sides by 4. And so if you notice, what we've done here is we've isolated the x squared. If the x squared is the only variable in your quadratic, then you want to isolate it first. 12 divided by 4, that's 3. And then you can simply take the square root of each side. Taking the square root of a squared term gets those to cancel. That gets x by itself. And anytime you take the square root of both sides, you do get a plus and a minus answer. Now, 3 doesn't square root nicely, so we're going to leave that in simplest radical form. You want to do that especially if it asks for the solutions to be exact. If you need those approximate, you can use a calculator to give you a decimal. But most of the time, they're going to want you to leave those solutions as exact answers. And I would also like you to notice that there are 2 solutions there. There's the positive square root of 3 and the negative square root of 3. Every quadratic has 2 solutions. Next, we're going to look at special case number 2. Here we are missing the constant. We have the ax squared, we have the bx, but there is no constant. So in this case, what you want to do is set it equal to 0. We are going to bring the 6x over, which will make it minus 6x. And then we're going to factor out the GCF. Now, if you're missing a constant, there will always be an x in common. So we're going to take out the x. And they also have a factor of 2 in common. So we're going to factor out 2x. That will leave me x minus 3. Once you have your equation factored, you can set each factor equal to 0 and solve. So we're going to say 2x equals 0 and x minus 3 equals 0. First, dividing both sides by 2 is going to give us x equals 0. And if I move the minus 3 over, that's going to give us x equal 3. And we're done. Remember I said every quadratic has two solutions. So those are the two solutions for that quadratic equation. And that does it for the special cases. Now we're going to move on to factoring. So moving to number 3, here we have a quadratic that's also a trinomial. We do have the 3 terms. And if I didn't specify earlier, factoring is the fastest way to solve a quadratic. So we're going to use our trinomial technique, how to factor a standard trinomial. Remember, the first step is parentheses. Second step, read the signs. Minus at the back makes them different. And the third step, fill in the blanks. X and x to make x squared. I need numbers that multiply to make 20, that subtract and make negative 8. And that is going to be 10 and 2, where the 10 does have to go with the minus. 2 minus 10 makes negative 8. Once you have the equation factored, you simply set each factor equal to 0 and solve. So x plus 2 equals 0, x minus 10 equals 0. Super easy from here. Moving the numbers over gives us x is negative 2 and positive 10. And that is done. And we are going to do one more example of factoring so that I get to illustrate my 3R method for factoring trinomials with a lead coefficient. So notice this problem is different than number 3 because we do have the lead coefficient. And if you're going to try to factor this, my preferred technique is the 3R method. So if you've not seen this before, the 3 R's are remove, replace, and reduce. So first, what we're going to do is we're going to remove the 3. That's going to give us x squared plus x minus. Now, when you remove the 3, you're going to multiply it by the constant. That's going to give us a 6. Now, if you notice, we have a standard trinomial, which is easier to factor. We've got our parentheses. We're going to read the signs, and we're going to fill in the blanks. X and x, numbers that multiply to make 6 and subtract to make 1. And that's going to be 3 minus 2. 3 minus 2 is 1. 3 times 2 is 6. Now, for the second R, we're going to replace. What did I remove? I removed the 3. Now I have to replace it. And do you see when I replace it, I have to put it in front of each x. And then we can do the third R, which is reduce. So in the first set of parentheses, I can reduce by 3. But in the second set of parentheses, nothing goes into 3 and 2 evenly, so that is not going to reduce. So we're going to have x plus 1 times 3x minus 2. That is factored correctly. At this point, we can set each factor equal to 0 and solve. X plus 1 equals 0. 3x minus 2 equals 0. And then the first factor is super easy. X is negative 1. For the other one, we're going to have to move the minus 2 over, which makes it a plus 2, and then divide by 3. And then we get x is 2/3. So there is another quadratic solved by factoring, illustrating my 3R method technique. Next, number 29. At this point, we're going to shift gears and we're going to move into completing the square. So, in order to complete the square, we do have to have all 3 terms, x squared, x, and the constant. And you do want the constant to be on the other side by itself. So this problem is already a step towards completing the square. So what we're going to do is we're going to recopy this equation and we're going to put plus, and I'm going to put a box because we're going to come up with a special number that we're going to add in there in order to complete the square. I'll explain that in a second. And remember, whatever you do to one side, you have to do to the other. So I'm going to repeat that plus box on the other side. Now, how do you get this special number that goes in the box? Well, the process of completing the square says you're going to take half of b, half of 6 is 3, and then that result you're going to square. And so that gives us a value of 9. Now remember, whatever you do to one side, you have to do to the other. So I'm going to add 9 to the other side. That is the completing the square process. Now, if you look at this new trinomial, this is now going to factor nicely. If we read the signs, they're both going to be positive. X and x to make x squared. And now look at this, numbers that multiply to make 9 and add to make 6, 3, and 3. And here's why we call that a perfect square trinomial. It's because these factors are identical and can be simplified to x plus 3 quantity squared. Now we do need to go ahead and combine like terms on the other side. 7 and 9 is 16. And bringing that down one more time. At this point, in order to get rid of a square, you can square root. So we'll take the square root of both sides. That's going to leave us x plus 3. 16 does square root. And remember, anytime you take the square root of both sides, you do need a plus and a minus answer. So we are almost done here. Next, we're going to move the positive 3 over. We're going to dump it right in front of the plus and minus. So that'll become negative 3 plus or minus 4. And the last step is to do the plus and the minus separately. So we're going to do negative 3 plus 4, and then we're going to do negative 3 minus 4. So negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. And those are our two solutions. Now, I don't know if I've said this yet or not, but if you're not sure if these solutions are correct, you can take them all the way back up to the original equation and plug in to check and see if they're right. So if I plug in 1, let me show that real quick, how to check. If I plug in 1, that's going to be 1 squared plus 6 times 1, and that should equal to 7 if it's correct. So that'll be 1 plus 6, which is 7. The other solution was negative 7. Negative 7 squared plus 6 times negative 7 should also equal to 7. Now, to stress this, when you're checking negative values, you do need to put those in parentheses. If you're using a calculator and you don't put the parentheses, you will probably get the wrong answer. Negative 7 squared is a positive 49. 6 times 7, that's negative 42. 49 minus 42 is 7. So both of those solutions do check out, and I do highly recommend that you check those solutions, especially on an exam. Okay, next, number 33. I figured we should do at least one more example of completing the square, starting from standard form. So here we have our quadratic equal to 0. If the instructions say solve by completing the square and you must show your work, here's how it's done. First, you're going to move the constant to the other side, which will make that a minus 25. And then we're going to recopy the problem, but we're going to put an empty space here because we're going to come up with our own special number that will complete the square. So on the other side, we've got 0 minus 25, which is minus 25. And remember, whatever you do to one side, you have to do to the other. So I'm going to put a special space over here too. Now, in order to complete the square, you take half of b, in this case is 4, and then that result you square. 4 squared is 16, goes in both boxes. That is the completing the square step. Next, this trinomial will factor nicely. So we've got our parentheses, we're going to read the signs, and we're going to fill in the blanks. X and X, numbers that multiply to make 16, that add and make 8, 4, and 4. Remember, those have to be identical if you completed the square correctly. X plus 4 times itself can be simplified to x plus 4 quantity squared. And on the other side, we do need to combine like terms. Negative 25 plus 16, that is negative 9. And then if I take the square root of both sides to get rid of the squared, we're going to have x plus 4 equals, now hang on a second, negative 9. You cannot square root negative numbers and get a real solution. But I can square root negative numbers and get a complex solution. So this is where you're going to have to know about complex numbers. The square root of 9 is 3, but since it's negative, that's going to give me an imaginary number. So the square root of a negative gives you the I. And don't forget, when you square root both sides, you need a plus and a minus answer. So that's going to result in plus or minus 3i. And then we got one more step to finish this off. We're going to bring the plus 4 over, which will make it minus 4 plus or minus 3i. Now, if they need you to write the two solutions separately, by the way, there are two solutions here. Those complex solutions would be negative 4 plus 3i and negative 4 minus 3i. So those are the complex solutions written separately if you need them. Next, number 55. The instructions say solve using the quadratic formula. So if I scroll up real quick and look at our notes, here I've got the quadratic formula written, which uses the values for A, B, and C. And so that means that our quadratic equation needs to be in standard form. It has to be equal to 0 in order to get the correct values for A, B, and C. So just know, if you're using the quadratic formula, your equation must be in standard form in order to get A, B, and C. And our equation is not in standard form. It's not equal to 0, so that is our first step. So we're going to have 5x squared plus 2x plus 2. And then I can see A is positive 5, B is positive 2, and C is positive 2. And now we can use the quadratic formula, and I like to refer to this as plug and play. So we're going to come up here to our quadratic formula and simply plug in the values for A, B, and C. All right, so once you know the values for A, B, and C, we're going to just plug into the quadratic formula. And I'm sorry, but I have a song for this that helps me plug and play. So I'm going to sing the song as I go. I, I don't sing very well, but I do like the song. Okay, so here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's the quadratic formula song. So now that we have the numbers plugged into the quadratic formula, we need to evaluate. And we're going to start with the radicand. We're going to evaluate the stuff under the radical. And by the way, that stuff is also known as the discriminant. -2 plus or minus square root of. And we need to work that out. Now you can work that out mentally, manually, or electronically. I'm going to choose electronically just to make sure. 2 squared minus 4 times 5 times 2. -36. Uh-oh, I got a bad feeling about this. It's negative. Do you remember what that means? I do. Get it? I do. Anyway, so the square root of a negative number means your solutions are going to be complex. So the next step is -2 plus or minus the square root of 36 is 6, and the negative is where I comes from. And that's not bad grammar. All over 10. And then if you can reduce, you need to reduce. So 2 goes into all three of these numbers, and I am going to write them in standard form of a complex number. So that's going to be -1/5. Remember, I divided by 2. 2 goes into 2 one time, 2 goes into 10 5 times. -1/5 plus or minus 2 goes into 6 3 times, so that'll be 3/5 I. And that gets our complex solutions in standard form. And remember, there are two solutions there. There's the plus and the minus. Every quadratic has two solutions. And number 75, here we have a quadratic function. The f of x, remember f of x means y. This is a quadratic function. And if it says find the zeros of the function, that's the same as saying find the solutions of the quadratic equation. So if you think about graphically, a quadratic makes a parabola, and the solutions correspond to the x-intercepts. Now, where do the x-intercepts occur? Well, they occur on the x-axis, and every point on the x-axis has a y-coordinate of 0. So that is why we're going to set this equal to 0. To find the zeros of the function means to find the solutions, which are the x-intercepts, of the quadratic equation. I hope that little bit helped right there explain why we set that equal to 0. So we're going to have 0 equals 5x squared minus 2x minus 1. This equation is in standard form. So we can see that A is 5, B is -2, C is -1. And we're going to use the quadratic formula again, aka also known as sing the song. All right, so here we go. X is equal to -b. Notice that b is already negative, so that's going to make it a positive. Plus or minus the square root of b squared -2 squared minus 4ac all over 2a. And that does it for our plug and play. Now we just need to work that out. So we've got 2 plus or minus square root of, and I'm going to need to figure out the discriminant, the radicand, the stuff under the radical. And I am going to use the calculator for that. So that is going to be -2 squared. Remember that negative numbers have to go in parentheses. Minus 4 times 5 times -1. 24. 24. Now 24 does not square root nicely, but I can break it down. So that's going to give me 2 plus or minus square root of 4 times 6 is 24. And the 4 can square root. So we're going to be able to bring the 4 out of the square root. And what is that going to give us? That's going to give us x equal 2 plus or minus the square root of 4 is 2, square root of 6 all over 10. And then, like we did back over here at number 55, if you can reduce, you need to reduce. So 2 goes into 2, 2, and 10, 1, 1, and 5. And my final answer is 1 plus or minus square root of 6 all over 5. And when I say final answer, I mean final answers. That is 1 plus square root of 6 over 5 and 1 minus square root of 6 over 5. Now, the question may come up that you need those solutions as decimal approximations. Okay, so let me show you how to input this in the calculator correctly to get these to be approximate values. If you have the Casio ClassWiz, you can do the fraction button, 1 plus square root of 6, move, and 5. So you can enter that as a fraction just the way it looks. If you hit equals, it's going to give you that back. Remember, you have to hit the SD button to force the decimal. And then you can simply back up, back, delete, and minus, and you can get the other decimal approximation. So not too hard with the ClassWiz. If you have a TI 83, 84, or another calculator that doesn't have a nice fraction button, what you can do is you can do parentheses 1 plus square root of 6. I'm going to have to move out from under the square root. And what this does is this groups the numerator together. This is all numerator divided by the denominator. And again, the ClassWiz is going to default to the exact value, and you can get the decimal this way with any other scientific or graphing calculator. All right, so that's going to do it for number 75. Now, if you've stayed around this long, as a special treat here, I would like to show you that the Casio ClassWiz has a built-in quadratic solver. And if you own the calculator, you might as well know how to use it effectively. So in the menu button, if you go down and over, one of your options here is going to be equation/function. So we're going to hit equal to select that. We are solving a polynomial equation of degree 2. Quadratics have a degree of 2. And notice here, all you have to do is fill in your values for A, B, and C, and then it's going to give you your answers. So let's check number 7. A is 4, so we're going to go 4 equals. There was no BX term, so we're going to go 0 equals. There's 0 X's, and minus 12. And I believe to do that, we're going to go negative 12. Because that is the value of C. C is actually negative 12. If I hit equals, it's going to give me the first answer. You see this? X1 is square root of 3. If I hit equals again, it's going to give me the second answer. And that is what we got for solutions, plus and minus square root of 3. So the only thing that you need to know about this quadratic solver is, okay, there's two things you need to know. Number one, you need to know how to get here. That was menu, equation/function, polynomial of degree 2. The other thing is you need to know that you've got to be in standard form when you plug in the values of A, B, and C. So like on number 15, I would have need to move the 6x over, and then I can plug in A and B. So A is 2, B is negative 6, and remember this, remember special case number 2, we were missing the constant. So you would put 0 for the constant, and then equals, it's going to give you x is 3, equals again gives you x is 0. Now you may be wondering, will this do complex solutions? All right, so to test to see if the calculator will give us complex solutions for number 33 here, we're going to go back to menu, to equation/function. Remember, we're doing polynomials of degree 2, and the value for a here is 1, b is 8, c is 25, and then if I hit equals, look at that. -4 plus 3i. If I hit equals again, -4 minus 3i. So the Casio ClassWiz is going to give us complex solutions. Okay, but will it give us irrational solutions? I wonder if it'll give me these answers exactly. Let's try number 75 real quick. So, A was 5, B -2, and the constant -1. And look at that. Now, another neat trick is if you're using the ClassWiz solver and you need this approximate, just hit the SD button immediately. Look at that. Bam. Back and forth. How freaking sweet is that? And if I hit equals again, there's the second solution. Bam, as a decimal. Man, this is a nice calculator. Can't get over how freaking nice this calculator is. Okay, so at this point, what I've done in this lesson is I covered the two special cases, which you really should know. We did factoring with and without a lead coefficient. We did the completing the square method, and I didn't do a very complex one of those. So if you need a more complex completing the square example, feel free to request that in the comments below. I wouldn't mind creating a video for that. And we looked at the quadratic formula. And that's going to do it for this lesson. So if you have any questions or comments about anything that I've covered, please feel free to leave that in the comment section below, or you can text me. And thanks for watching.